Alright, the last thing this section covers is solving polar systems of equations. So you can see down at the bottom of the page there, I've got some directions, some different sets of directions, and I'll talk you through those. The first thing it asks us to do is graph the system of polar equations. And I don't need you to do that by hand. You can put it on the calculator. And that's to help you kind of get an idea of how many answers you're going to have and about where they should be. So the first set of directions tells you to do that, and then it tells you to solve the system using algebra and trigonometry. It's telling you to assume theta is between 0 and 2 pi. So we're trying to find all the answers for theta for this system between 0 and 2 pi. So to use algebra and trig means to manipulate this. Use some trig identities, solve a trig equation. So since these are both r equals, what I'm going to do is I'm going to substitute this in for r into the other equation. So we end up with the trig equation sine theta equals the cosine of 2 theta. Now one of the reasons why we spent some time in the trig unit on solving trig equations is because that's exactly what we need to be able to do here. In this case, we're going to be using a trig identity for the cosine of 2 theta. Now there's 3 identities to choose from for the cosine of 2 theta, but I want to use the one that has sine in it. So that's 1 minus 2 sine squared theta. Now I've got all signs in the problem, and I recognize in this question because of the squared that I'm going to have to factor. So I'm going to actually move everything over here to the left side. So positive 2 sine squared theta, so I'm going to add this term over. I've got a positive sine theta, and then I'm going to subtract the 1 equals 0. So I'm taking these terms and moving them over to the left side of the equation using addition and subtraction. So that allows me to factor this into 2 sine theta times the sine of theta. I know lots of you on the last test, you knew to factor, but for some reason you moved the 1 over to this side. If you're going to use factoring as a method of solving, you have to have a 0 on one side. That's because of the zero product property. If factors equal 0, then we know either one or the other equals 0. So to get this factoring finished correctly, I'm going to do a plus 1 here and a minus 1 here. And that way I end up with the plus sine theta that I need in the middle. So setting each of those factors to equal to 0, I get sine theta equals 1/2 and sine of theta equals -1. And here again is making sure I know, my answers to these kinds of questions. So we're answering here in radians. Sine of theta equals 1/2 when the reference angle is a 30-degree reference angle, so a pi over 6 in radians. So pi over 6, and then there's a second answer to that because sine can give us a positive 1/2 in 2 quadrants. So it can also give us an answer in the second quadrant. So pi over 6, and the second quadrant answer that would correspond with that would be 5 pi over 6. So 30 degrees and 150 degrees. Now sine of theta equals -1, and that only happens one place. The only time that sine is -1 is at 270 degrees, or 3 pi over 2. Okay, now that's not my final answer to this because we wanted to be able to find the points where these actually intersect. So we need to probably list these as ordered pairs. So I'm going to take my values of theta, which is the second value in an ordered pair, and I'm going to substitute those back into either one. And I'm going to use this first one here. It seems a little bit easier. So when the theta is pi over 6, then I'm taking the sine of pi over 6, which I know is 1/2. So that's one place where these two equations intersect, and I should be able to hopefully see that from the graph. Another place where they intersect would be at 1/2 and 5 pi over 6. And then this spot would be -1, 3 pi over 2. And so hopefully when I graph that on the calculator, it would confirm that. Now the other way you're going to have to do this in your homework is to graph it on the calculator, but not just graph it on the calculator, to actually solve it on the calculator. So you would do that the same way you do by any graph. You would find the points of intersection. So you would need to go through the steps of getting to your intersect command and being able to find those points of intersection. And then that's that. So your assignment is on the last page there. And please follow the directions for the numbers 11 through 22 because I don't want you graphing those by hand by plotting points. So again, just follow the directions that are given there, and there will be a quick quiz on this on Monday. So tomorrow we're going to work on section 9.3, and then Friday's going to be a work day, kind of question day over 9.2 and 9.3, and 9.1 if you still have questions on that. 9.5 we'll come back to later. We had to go a little bit out of order because of my hospital stay. And then Monday we'll be ready for that quick quiz.